And now we're going to bring it to the actual elements of a test framework. We're going to break each of these out a little bit. Jeff, I'll let you take lead on this one.
Ooh, fun. All right. So I guess the first part to start is with the library. So these are the pieces that you're stitching together to build out more complex workflows, right? What's the purpose of that framework? Well, from way back on slide number 5 or 6 or whatever it was, we want to be able to link tests to other items. We want to be able to create tests quickly. And we want to separate some of the layers, like data and the logic. Why are we doing this? So that we can start with something that is fundamentally easy to trace and easy to build in. That starts with a good library. What's a library? Well, it's pretty much what you would think it is. It's a big giant selection of all of your decomposed scripts down to those atomic levels. So an example of that would be the 2 input sections from our example with the ROI. Workflow 1 had a section of just entering things in the slider. Workflow 2 had things entering it in the text. Each one of those is a separate item in the library. And they are completely separate from the last piece, which is where I was checking, contact us and print us and all the results. So wow, I love doing things for QA people. Did you notice that the test environments were broken out by tape?
I did not.
Yes, apparently broken up by tape instead of type. leave it to a QA audience, right? So where does that start, right? So we got this whole library of actions. We also have separate from that the data. Now, how much and how to get the data, that's a very, very big topic. But the intent here is that for every set of input and actual results, you have at least one data source. Those data sources are what you're going to stitch together with a library, along with helper functions, which is just a kind of catch-all for stuff that isn't actually in action, isn't data, but it's the things that just help you out, right? Clean up scripts to scrub the database when you're done, set up scripts to set up an environment for you, tasks that you might not think of, like let's go capture the database table that the user can't see so that we can compare against that.
Mm-hmm. Yeah.
And then test environments, I'm going to leave for you since now they're broken out by tape.
Thank you for pointing that one out to me. Who was it? Daryl. Thank you. I appreciate it. And so, we've talked about this. Operating systems, browsers, types of devices, this is only going to continue to explode. And so, that is a whole separate consideration when you build out your test framework. However, these can be most successful when you combine them with associated helper functions, such as your setup scripts as well as accessing information. And your helper functions, just as Jeff had said, it really is that catch-all. So it's really nice to have setup scripts for a Mac device that's working with Safari, or a setup script for a Windows machine that might work with Internet Explorer a bit more. It can save you a lot of time.
Yeah, and importantly here, you'll notice that they're all separate. We're not just saying these are all things you need. These are all things you need, and you keep them separate. So a list of test environments and the associated artifacts for that environment is actually separate from my data, and that's separate from the actions of the script.
So let's get into our last section here, Jeff. I'm going to let you kick it off for elements of a test framework.
Sure. So what did we just do with all that stuff we just put in the framework in separate items? Well, what we've done is build a system where I can build bigger pieces. Those bigger pieces, there's 100 names for them, but I'm going to call them modules for the purposes of not giving you a ton of jargon. This is just the combination of your library items with their helper functions, plus the test data sources, plus running it all in environments. This modules is how you're able to track things back more easily. Usually, people will start with trying to trace a defect to the workflow you're trying to go through. and then back to the requirement that workflow is meant to capture. But this is a nice, clean, easy example. It's why we use the ROI example piece. We're going through and we're saying, great, go run workflow 1, use data source A, and then do the checks using that same data. Then do the exact same thing in workflow 2, and we're doing the checks again with that data. And then we're going to the common piece for running it through each environments. Why did we not do workflow 1 inputs, then workflow 2 inputs, then check everything? Because when this fails, I can now pinpoint, is it this workflow 1 or is it workflow 2? So you want to actually have a check for every form of input. Is kind of where that was going. So
Yeah.
Bria, did that make sense? Was I too boring on that one? Put everybody to sleep?
You put me to sleep, but I woke up. It's okay.
Okay.
To talk about structures and hierarchies.
Oh, I'm going to leave that one for you.
Oh, thank you. You know, I think this was a reason I was curious about what people are using for their test management tool is I'm really curious how people are linking things and what structure they're in. And so, you know, just like you might have a binder with dividers in it, it's really nice to have type of folder structure modules. You might also do this in your inbox with your email. So it's nice to be able to have a release that encapsulates everything. And then maybe under that you have a test set. And then under your test set, you have multiple tests. And then within your test, they're probably linked to both requirements as well as defects. But they're all under this head folder, and there are these parent and child relationships that you can use. And so it's really important when you're setting up your framework to build out these relationships. It's going to save you a lot of time. An example is, you know, you get a defect, and you're like, dang it, where did that defect come from? It's really nice if you already have this structure and build out to where you know you can trace your defect to your test set, to the specific test, to this release, or sorry, to this requirement, which is in this release. So leaving a structure and hierarchy, having that type of standard when you go out to building your test framework can really pay off in the long run.
And this is important because this should, most of the time, it reflects your application under test. You know, the structure of the actual framework should, in some manner, the modules, match the user stories to areas of the application. But this is the part that people tend to skip or not think of if they approach the test framework as only automation. Because they start building their structure and hierarchies the way a developer would. Mm-hmm. Instead of capturing workflows and filling in the workflows with developed assets like automation scripts. Absolutely. And if you come at it the right way, you find that you can combine automated and manual correctly, that you can have this structure around it so that if a piece fails, you're very, very quick to pinpoint the exact area of the failure. And the quickness is one of the key values here. A good framework lets you be more agile. It lets you go faster. It lets you actually hand the developers stuff that will let them fix the bugs quicker so it gets back into retesting faster. A good test framework is generally a very important part of being able to have a modern development cycle.
And to build off that, not only are you going faster, but you know what you're covering. You know you're getting the right test coverage. You know that you're still testing everything that needs to be tested, so you're not sacrificing any quality. And having that structure outlined from the very start allows you to accomplish both of those things.
Right. So, you know, we already kind of covered, I guess, a good chunk of the next slide because we just can't shut up and we're like that. But, but yeah, I mean, at the end of the day, you're going to be tracing all of this stuff back. You're going to have defects that you need to trace back to requirements especially. The purposing behind that is, I hope at this point, clear, right? This is a way that you can actually build test plans quickly. So if you end up with a defect from one of this kind of a framework's approach, you're able to trace it back. Sure, that's great. But if you think about the bigger piece, how do I know what I need to test? It's a list of everything that changed, and that list is now your test plan. So I see a lot of people still, especially in the manual world, building out complex testing plans. And realistically, a good framework hands you the plan just by knowing the relationship to what's changed. So I do see a question in there about what about regression testing. What's a regression test? Well, a regression test is testing all of the previous defects that failed. Okay, yep. So that means a list of your common common, help me out here, Bria. What's the word I just keep using that I just forgot? Workflows.
Workflows.
Yes. It's a list of your common workflows. You put the most common together, keep it simple, you've got a smoke test. You put a lot of the ones that fail a lot together, and you've got a regression test. Oversimplifying, but that's how it goes.